Hello everyone. Today I'm excited to present Vision AI, a production-ready chatbot application built on top of the Qubrid AI platform powered by the Qwen3 Vision model. In this walkthrough, I will demonstrate how Qubrid APIs enable us to build a fast, scalable, and real-world AI vision system without worrying about infrastructure, GPUs, or deployment complexity. I'll start with a quick live demo, then explain the architecture, and finally walk you through the front end and back end code base in detail. But before that, let's look into Qubrid's platform. Qubrid AI allows us to leverage a single API key to access hosted state of the art models. The platform provides GPU powered compute, seamless deployment, and optimized inference, enabling us to enabling us to access models across OCR, vision, audio, image, code, and text, all without managing any infrastructure ourselves. This makes Qubrid AI an ideal platform for building real world AI applications. Now let's move to the demo. This is our application interface. Every intelligent interaction here is powered directly by Qubrid AI API. In this upload image section, I will click on browse files. I will select an image, open it. You can view the image here. I will add a prompt. Describe this image in detail and explain what is happening. As soon as the input is submitted, our backend sends a request to Qubrid's endpoint and the response is generated in real time using the Qwen3 vision model. As you can see, the model has given a detailed breakdown of the image according to the context of the image. This shows how our Vision AI can understand an image and describe its content in natural language. Now let's move and click on another image. I'll choose this one. You can view the image and I can add the prompt to it. Generate a short engaging caption for this image. Let's see what it responds. Wow, it gave a very good response even with hashtags. So you can see how this is useful for automatically generating captions for social media or marketing content. Along with the real-time intelligence, our application also maintains conversation history. Users can seamlessly switch between the conversations and use different chats, revisit previous interactions, and continue conversations without losing context. I can again start conversating can ask where the lion is standing, and it will only give me answer to in respect to this image and according to the memory of this chat. So see how well it responded me. This makes the experience more natural and practical for real world applications and usage, especially when working in multiple tasks. Now let's move to the architecture. In the architecture we have 4 layers. In layer 1, user interface, which is the Streamlit front end, which we just saw, the welcome screen, sidebar controls, chat interface. Then comes the main layer 2, application logic, app.py. It consists of session state initialization, conversation lifecycle management, message handling and streaming coordination, UI rendering and component orchestration. This we will see in our code demo. Now layer 3 consists of the important modules, chain module, utils module, prompt modules, and client.py. And in external API, it's the Qwen3 is the Qubrid AI platform API key through which we are accessing the model Qwen3-VL 30BA3B instruct, and the capabilities are multimodal vision language processing, image understanding, and analysis and streaming responses. So this is what a quick overview of the architecture is. Now let's move towards the code. Okay, so here you can see we have the backend, front end, a .env file for for our API credentials so that they remain secure and not be used in the code. So now let's start with the foundation image processing. In the backend we have utils.py. The utils.py contains 2 small but critical functions. First is encode image to base 64 and the second is prepare image for API. This function takes a PIL image. This encode to image base 64 function takes a PIL image, saves it to bytes input output buffer as a PNG, and then converts it to the base 64 string. This step is required because we can't send raw image over HTTP request. Next is prepare image for API. This function wraps the base 64 string into a data URI format and followed by the encoded image. This is the exact format expected by the Qubrid Vision API. Now let's look into prompt.py. Okay, and this is the file defines how the AI should behave. The prompt instructs the model to only describe what is actually visible in the image, never hallucinate or guess anything, be clear, helpful, and conversational, explicitly state uncertainty when needed. This is extremely important for building reliable and trustworthy vision AI systems. Now let's go and look into Qubrid client.py. This file handles all the communications with the Qubrid platform. The Qubrid Vision LLM class initializes using environment variables, as you can see. You can get your Qubrid API key from the Qubrid AI platform. The most important method here is the stream method. It builds the request payload with messages and model parameters, as you can see, sends a post request to the Qubrid with streaming enabled, stream is set is equal to true, listens to the server sent events, and yields partial response back to the caller. This streaming loop is what enables the real-time token-by-token responses you saw during the demo. Now let's move towards change.py. This is the heart of the entire application. The Vision Chain class orchestrates everything using LangChain. During initialization, it receives the LangChain memory instance, creates the Qubrid client, and loads the system prompt. The helper method format message for API converts LangChain message objects such as send message, AI message, and human message into the role-based format expected by the Qubrid API. The build method is especially important. It adds the system prompt first, retrieves the conversation history from LangChain memory, formats each historical message, appends the current user query along with the image base 64 encoded. Notice that the current message includes both text and image content, following Qubrid's multimodal format. Finally, the stream method ties everything together. It builds the full message list, adds the user message to memory before the API call, streams the response from Qubrid, accumulates the final response, and adds the response back to memory after completion. This automatic memory handling is key. The frontend never has to manage it manually. Now let's move to the frontend. It consists of UI components.py. Okay, this file contains all reusable UI logic. The welcome screen provides the instructions for new user, sidebar handles model parameters, conversation history, image upload widget, buttons for new chat, and resetting parameters. The function returns all parameters and the uploaded image to the main app. Now let's move to the base config.py. This file contains all the custom CSS. We override Streamlit's default styling to create a premium dark theme aligned with Qubrid's branding, including buttons, chat, inputs, and layout spacing. Now let's quickly get a walkthrough of app.py, which acts as the main orchestrator of the application. We start with the page configuration and global styling. We set the app layout and title and apply our custom CSS for consistent branding. Now in the initialization state function, it sets up everything we need across regions, conversation storage, the active conversation ID, LangChain memory, and a shared vision instance. The get banner base 64 functions simply loads and embeds our branded banner directly into the UI using the base 64 encoding. For conversation management, we have create conversation and switch conversation. From the name itself says, create conversation creates a new chat session whenever a new image is uploaded, while switch conversation clears and rebuilds LangChain memory so the AI regains full context when switching chats. The add message to conversation function stores message only for UI rendering, keeping model memory completely separate, and active conversation fetches the current chat state. Inside the main function, we render the header, sidebar, and if an image is uploaded, a new conversation is created and activated automatically. When a conversation is active, we display the image and replay chat history, and wait for the user input. Once the user asks a question, the message is displayed immediately. Um, then sent to the vision chain, which streams their response token by token in real time. If no conversation exists, we simply render the welcome stream. So overall, app.py focuses on UI flow and state management, while all AI logic lives inside the vision chain. Now let's conclude. To conclude, as we can see, Vision AI plays a critical role in solving real life use cases, from visual understanding to intelligent reasoning. With Qubrid AI and the Qwen3 vision model, we are able to bring capabilities into real products quickly and efficiently. Now it's your turn to explore Qubrid's AI platform. Whether you are building Vision AI multi-systems or intelligent applications, Qubrid provides everything you need to move from idea to production. Thank you for watching.